In 8.1, which we are merging with section 1.6, if you need to reference your book, we will be able to classify polygons, and we will be able to find interior and exterior angle measures. That's our goal by the end of this lesson. First, let's talk about what is a polygon. A polygon, some notes to know about it, is a closed plane figure. It's closed. It is formed by 3 or more line segments, and these line segments are called the sides of the polygon. Each endpoint of a side is called the vertex. And no more than 2 vertices, the plural of vertex, no more than 2 vertices lie on a segment. So some shortcut things to think about as we look for which of these figures are polygons. Closed plane figures. So closed. Which one of these is not closed? This last one is not closed. So this one is not a polygon because this one is not closed. What else? A closed plane figure is what we're looking for. None of these other ones are open. Formed by 3 or more line segments. So segments, we want to think of not curvy, straight. Okay, segments are straight, not curvy. So of these pictures that follow, this one not made up of segments. What else? Each endpoint of a side is a vertex. That's just what it's called. So here's a side. It has a vertex right here. No more than 2 vertices lie on a segment. Here's a segment, 2 vertices. Here's a segment, 2 vertices. What we might be looking for in that last example is something like this. This is like 2 polygons put together, and I see that there is a segment right here that has vertex, vertex, vertex. That's more than 2 vertices, so that one is not a polygon. I'm going to color code that a little bit differently so that I can outline. Here's the segment. It has 3 vertices on it, more than 2 vertices, therefore it is not a polygon. So of these last pictures, they are polygons. This is a polygon, this is a polygon, this is a polygon. Closed, straight sides. There are 2 types of polygons we are going to study. One is called convex, the other is called concave. Perhaps you have a highlighter or you want to underline some of these main words. If you have a highlighter, you probably want to highlight the words convex and concave so that you remember them. Polygon, also an important word for us to remember throughout this lesson. So what is convex versus concave? Convex is defined as the following. No line containing a side also contains an interior point. What does that mean? Basically, if I take any of the sides that are here and I trace over any of the sides, it does not go into the interior of the polygon. No line containing a side. So if I trace a side, it will not go into an inside of that polygon. So for example, any side I trace over here stays on the outside. This one, therefore, is convex. Here, if I pick a side such as this side and I trace it and I keep tracing it, now I've arrived at the interior. It's reached an interior point. So this one is not convex. And if it is not convex, we call it concave. This is an example of a concave polygon. Concave we can simply define as not convex, not convex. So again, just to think of convex, think of it as trace over a side and it does not, the line does not, so maybe I should say trace over a side and the line does not go inside the polygon. That's a way that we can think about it being convex. So how about the last figure, the one that we would call a triangle? Any of the sides that I would trace over, notice it stays on the outside. So this one is convex.